9 in the note packet. Today we're going to talk about percents. Once I give this, some of you might know this actually already. So on the notes here, the percents, what you want to talk about is there's going to be different types of questions that are short, like this, like what percent of 56 is 42? What percent of 40 is 2.5? And then there's like a story problem, okay? So there are two ways to kind of remember how to do this. And I just copied this, but basically you want A and B here. This is part and whole. So when you're doing any sort of story problem, and this works for all problems, you want to use this shortcut basically. Part, and write this down, over whole is going to be equal to whatever your percentage is, not as a decimal, over 100. And the reason it's over 100 is because 100% would be considered like one whole, right? So this works all the time for everything. There is a shortcut or a cheat for these shorter ones that you can use as well, okay? And the cheat is using the words around it. If you use the words is over of equals percent over 100, okay? And again, it only works for these shorter problems, not the story problems. You can use the words around the numbers to kind of know where to put them. So in the end, you're going to solve a proportion like we've been doing leading up to this. You can kind of tell that because there's two fractions equal to each other. And so that's how you got to set it up. Okay, so let's look at this first one. What percent of 56 is 42? So if you think about this, the first thing I do is I set up the skeleton of a proportion, meaning like nothing's in it. That's the skeleton. And then I always put the 100 in for these. Disclaimer, you can, if you're walking through like something on our online textbook, sometimes they will move that 100 to the other side. They'll flip it around. That's okay, as long as they do the part over whole, all right? So now I look in the problem and I go, is there a percentage symbol in this problem? And the answer is no. So you know right away that's what's missing. So that's our x or whatever our variable is, because there's no percent sign. And then I say of 56 is 42. So this of goes with the 56 and the is goes with the 42. So if you look at that, is on our cheat is on the top. So 42 is on the top and of is on the bottom. You can also think of that as 42 is the part, 56 is the whole. Okay, once you have it set up, it's easy peasy, right? What do we cross multiply? What do we cross multiply? Xavier, what do we do?
56 and x.
56 and x, yep. And then equals now, what do we multiply on the other side? Go, Donovan. 42 and 100, yeah. And some of you can just do that in your head, right? Yep, 4,200 is what that's going to be. And then what do we do to finally solve it? We divide. Yeah, divide by 56. Okay, and so if we do that, x equal 4,200 divided by 56 equals how much? Go ahead, Xavier.
75.
75. And this answer, since it was the percentage, is 75%. So 40, what that's telling you is 42 is 75% of 56, right? If you got a 42 out of 56 on a test, you would get a 75%. That's what that means. Okay, now they will switch this around a little bit, okay? So in the next problem, it says, what percent of 40 is 2.5? Okay, so do it again. Set up the skeleton of the proportion. 100 is something that always has to be in the percentage problem, so put that in. Look for the percentage symbol. Is there one in this problem? So again, since there's not, let's make that our x. All right? You can either use the words or use part and whole. So what percent of 40 is 2.5? So where does each number go? Where does 40 go? Where does 2.5 go? Rebecca, where do they go?
2.5 goes on the top and 40 goes on the bottom.
Perfect. 2.5 goes on the top, 40 goes on the bottom. Of 40 is 2.5, part and whole. Okay, cross multiply. And this is the same direction as before. 40 times x on one side, that's easy, 40x. And then 2.5 times 100 on the other side.
250?
Yep, 250, good job. And then what do? We divide. We divide by 40 here to get rid of, to cancel that out. Divide by 40 here. And 250 divided by 40 equals, go.
6.25.
Yep, and that's fine. Can you have a decimal in a percentage? Can you have 6.25%?
Yes.
Absolutely. Yep, definitely. When you guys get a little bit older and you start getting like interest rates for loans and stuff, there's almost always decimal percentages when they're doing interest rates and things like that. Okay, now where this is over of situation does not work is in a story problem. Okay, so here, problem 3, you can't use that cheat. You have to use the part over whole situation. All right. A dress shirt that normally costs $38.50 is on sale for 30% off. What is the sale price of this shirt? Now, disclaimer, there are multiple ways to do this that are shorter. I'm going to show you the proportion way. But if you're like in the store, there's a shorter way to do it in your phone or whatever, you're calculating in your head. The proportion way is this. Okay, set it up. 100's got to go in still. All right. Now, is there a percentage here?
Yes.
30% off, though, right?
Mm-hmm.
So if it's 30% off, what are you actually paying? What percentage? 70% of it is what you're paying, right? If it's 30% off, so the percentage when it's off is going to be 70% up there, okay? And I put the percent symbol in just to show you, but we're not going to put that in a calculator. All right. If the shirt normally costs $38.50, is that the part or the whole? That's the whole. So that's got to go at the bottom. Meaning what we're trying to find is the discounted price, the 70. If you're only paying 70%, that's how you set that up. Okay? So what do we cross multiply?
70% is $38.50.
Yeah. Yeah, and I like to put the X on the left. So I'm going to do 100 and X first. And then I'm going to do the 38.50 times 70. Now that one I wrote out because I don't know 38.50 times 70 in my head. Okay? So let's figure out what it is. 38.50 times 70. Okay, so 100x equals 1,695. 2,000, thank you. All right, and then we divide by 100 to cancel that out and to get our final cost. What is it? 2,695 divided by 100.
26.95.
There you go. And that's in money, right? $26.95 is the sale cost of that shirt. Now, does anyone know the way that you probably will do it in the store? Do you know, Donovan?
Don't you divide 38.50 by 70 or is it 30?
You multiply it.
Oh, you
Okay? So there's two ways you can do it. You can calculate the discount, right, by doing 0.3 times 38.50, then subtracting that from the amount. Or you can think about it like, okay, if it's 30% off, I pay 70. Well, what is 70% as a decimal? It's 0.7, right? Because you got to move the decimal over 2 spaces. And if you just multiply that by 38.50, you will get 26.95. This is the shorter way that you can use to find a sale price. Now, why am I showing you the proportion way? Because they're going to be asking you how to do it, and it's super important to realize where that actually comes from, okay? All right, can I use the shortcut on problem 4, finding the base one? Yes. Problem 4. Yeah, you can. You got that shorter situation. It's not in a story problem. So also, don't be afraid of 125%. Does that exist? No. Think about, like, have any of you ever seen a copy machine, like, up close? Yeah. Like, if I want to make something bigger on the copy machine, I can click the plus button on it, and I can blow it up to 125% or 200%, and it makes it bigger. Same with, like, photos and stuff like that. If you order them, you can blow them up by a percentage. Okay, so set up the skeleton again. 100 has to go in. Where does 125% have to go? Where does that have to go, Cody? On top of the 100, because the percentage always goes over the 100, even if it's 125. Okay, so that one's out, right? So 17.5 is closest to the word is. That's your hint, right? So if you use our cheat, where is the is? On the top. And that's the part, right? So 17.5 goes here. And the x would go at the bottom of there, okay? We're looking for the whole. 125% of what number is 17.5? Okay, cross multiply. X times 125. That one's easy. And then the other side is 17.5 times 100, right? What is that?
17 or 1,750.
Okay. And then what do? We divide. 125. Okay. And now we're looking for the whole here. What do we get? Say it louder. 1.5? Can I get a second on 1? 14?
Yeah.
Just plain 14?
Yeah.
Okay. That's the whole. So, like, if it was like a photo that was 14 centimeters, right, and you blew it up by 125%, now it's 17.5 centimeters is what that means. Okay. I wanted to make sure that we included everything we could here. The other part of this is called simple interest, okay? So turn that over. I just included the key concept. I just copied it for us, okay? And what this stands for is interest is I equals principal, not like times rate times time. Okay, is what that stands for. And interest is money you earn on your money, right? So, like, if you put your money in a bank account, you can earn interest just by leaving it in the account, okay? You earn money on your money. People, like, if you take a loan out, the bank will charge you interest the longer you have the loan out. That's actually how banks make money, okay? They charge you more interest than they pay out. Like, they pay you interest for keeping your money in their bank, but they charge interest for people who take loans. They charge way more interest than they pay out. So that's how banks make their money. So, like, if you have a home loan or a car loan or a loan, you're paying way more interest than you're actually earning for having your amount in there. Okay? Now, how you calculate simple interest, that means it's just a one-time deal. It's not compounding on each other. Is the principal. Does anyone know what that means? It's not like the principal of our school.
Like a rule?
That's another word for that, but it's not this one, though. It's the original amount of money. Okay? The principal is the amount. Like, if you put $1,000 in the bank account, that's your original amount. That's not with the interest on it. okay, times the rate. So that's always going to usually be our percentage, right? So like at your bank, you want to shop around for the bank that's going to pay you the best rate for the amount. If you want more money, you can do something called a CD or a certificate of deposit. And that means you are going to agree to keep that money in there for, let's say, 5 years and not touch it. They'll pay you more, okay? And then the time that it's in there. So here's an example. You deposit $840 in a savings account that earns simple interest of a rate of 4.5% per year. You want to keep the money in the account for 4 years. How much interest will you earn? Check your answer for reasonableness. Okay, so what this means, to find the interest, we're going to start with our principal, which is the original amount. $840 is what we start with in the account. You multiply that times your rate. Now, your rate is the percentage, but you have to put it as a decimal. So 4.5%, what is that as a decimal? How do we get that into a decimal? Does anyone know? Percents to decimals. Go, Nathaniel.
Divide by 100.
You divide it by 100, yes. So if you do this and you divide by 100, it really is the same as moving the decimal 2 places. Which direction?
To the right.
To the left.
Oh, yeah, left.
Yep. So our rate really in this case is 0.045. If you're unsure, go ahead, divide it by 100 to be sure, right? So that's our rate. And then what's our time here? 4 years, right? And so if we do that, this will calculate the amount of money the bank will pay you just for keeping your money in that account for 4 years. Go ahead, do it. 840 times 0.045 times 4. What do we get? 151.2? And that would be 20 cents. So let's say you're just saving that money at your house, right? And you're not touching it. It's wiser to save it in a bank account because you earn, for doing nothing other than keeping it in there, you earn $151.20. Okay. Right. And a bank has insurance on it. So if a bank gets robbed, they're backed up. If you get robbed, you're out that money. You know what I mean? So you might as well keep it in a bank account and let it earn interest if you are not going to touch it, right? Okay, so that's how that actually works. All right, that's a lesson today. So I'm going to post the lesson for everyone who's not here. If you are in my class, the practice that goes with that is 2-9 practice, and we're only going to do the even numbers. If you are not in my class, hopefully that was helpful to you.